responsibilities during this. So first off, let's go over our house rules. I think Dr. West covered these just a little bit earlier. So during your small group discussions, if you know the answers, keep those answers to yourself. You will, your only job then is to ask questions of your partners. And this will enable them to kind of process it themselves, and that makes the knowledge stick a little better. Oh, good. Okay, and then during large group discussions, you should listen to the speaker, and please don't have any side conversations. While you may already know things, the other people around you might be distracted and not understand and need to know the information. I don't know. Oh, in your composition book, you can write your questions like a parking lot, you know, for questions that you can answer or ask later. In your group, you're going to have different roles. There are tents on your tables. There's 4 different roles, so you can take a look at those and distribute those amongst yourselves. So everybody gets a role. I'm going to give you about 10 seconds to do that, please. And this is going to be your role for the day. The title is on one side, the description is on the other. Okay. Now, I want you to obtain on your table, there's some Ziploc bags. On your table, there's some Ziploc bags. I want you to pull out the one that has the cylinders of equal size, please. Obtain the bag that has the cylinders of equal size. Pull out all 4 cylinders. Now, in your study guide, you can look in your yellow study guide. It's on number 1, not that one. You cannot lose yourself. It says, how thick is it study guide? This one right here. Number 1 has a space for you to describe how the two equal size samples or cylinders are similar. So you're looking at 2 of them, so you can share. Compare 2 of the cylinders and write down their similarities. Any 2. So you can do, you guys can do 2 and you guys can do 2.
There you go.
Okay, so you have written down your similarities and you've written down your differences on the equal size cylinders. So now I want you to put those aside, put them back in the bag, and grab, there's another bag that has cylinders. Okay, let's come back in. Grab the bag that says mass on it. Those are cylinders of equal mass. Now, independently, without talking, we're just writing right now. Don't consult your people. Grab two of them. So each person will be observing two cylinders of equal mass. I want you to write down the similarities. This is number 2 on your study guide. Describe how the two equal mass samples or cylinders are similar. And we're just writing this time.
Table's really looking at their cylinders and really looking at how they're the same.
Okay, now write down their differences. You've made your observations on the similarities. Now make your observations for the differences. Okay, we're just writing, guys. All right. Now's when we're going to talk about it. I want you to discuss with your partner how the two cylinders of equal size are similar and different.
That works.
How are the two cylinders of equal size? So that was the first set that you looked at. You're discussing.
We're comparing this to
No, you're comparing the two. How are they the same? What
and now we're talking. About earlier. We already got okay. So now it's just a sharing. Visually, you just want to look at it. It's hard to.
Change that. Okay, now discuss with your partner how the two cylinders of equal mass are similar or different. So now we're going to go to that second set that you observed. Discuss with your partner the similarities and the differences.
By size and color. And what they're made.
That's the top.
Yeah.
Is that what you were, was it size, color, and composition? So what's in gray? They're both solids. What do we know? There's a because volume.
All right, let's wrap that up.
Yes.
And when you're done with those, please put your cylinders back into the appropriate bag. And pull out the 2 baby food jars that are in your box, in your basket.
The kids would be like, no.
So I think that question's gonna get answered in class.
And everybody's gonna share these. Okay, so what we're gonna do is we're gonna look at these baby food jars. One of them is full of washers, and the other one is full of cotton balls. I want you to look at those and think about these questions. How are these 2 samples similar? How are they different? And that's not something you're writing down or setting up. You're just looking at these and think about how they're similar and how they're different, and discuss that with your group.
Those objects are round. They're both the same.
Probably the exact same size, so roughly the exact same volume. Okay. So let's talk about these. I want the materials manager over here. Tell me the similarities that you guys observed in your. We have the same basic shape and size. They look, since it's basically the same shape and size, I figured they probably have the same volume. They're both made of the same general materials. You have glass, you have the metal up there.
Okay, thank you. Thank you. Did anybody have anything different? Come up with another observation in addition to that. Okay, and that's absolutely fine. We're gonna, even though the color of the lids or the brand of the jar may be a little different, those jars we're gonna assume are identical. Okay, so how about those differences in the contents of the jar? Reporter, let's see. Okay, you had your hand up. Go ahead and tell us what you guys observed.
The differences from these 2,
Yes.
the washers obviously have more mass than cotton balls, way more.
Okay, the washers had more mass than the cotton balls did. Okay. Can you tell anything else? Okay. Did anybody else have any additional differences they'd like to share?
And more densely packed. It looks like the cotton balls are more densely packed in there since there's less empty
Open
space left.
space, okay. I see what you're saying.
There's more washers compared to the little cotton balls, there are more washers.
How do you know that?
Because looking at here, I'm just counting based on the washer, I'm thinking at least 40 cotton balls, because they take up more space, they expand more.
Okay. Good, thank you.
Those are some great observations.
And I want to say something as a novice.
Yes.
Before it's like these, I did not understand how these were the same mass by looking at them. I've never had any experience with this. So I did not believe that they were the same mass as by looking at them.
And were your partners able to explain it?
Yes, because they had me learn how to use the scale and then weigh them. So I've never worked with a scale like this, and I've never seen these things.
They didn't have triple D balances.
Yeah. I'm just kidding. I know. They didn't, but I haven't had that science at all, so. If you might have a principal
Volume means,
Volume means, and then you say what volume means.
Volume means what? Oh, never mind. I'm listening, I'm still good.
And this is your definition, don't think
It
we're
doesn't
asking
have
you
to
to
be
come up
exactly right, just what you think it is.
Okay, I'm gonna give you about 30 more seconds. Now, some of these words may be a little more familiar to you than the other ones. So don't worry about this, we're gonna get into these a little more. And you're gonna have an opportunity to revise your definition. So you're all pretty familiar with what volume is, and pretty familiar with what mass is. But density is a little bit more difficult, and that's the reason we're here today. So a lot of people are confused about density, including Marty McFly, who, I don't know if you remember in the movie, he said, oh, your density instead of destiny. Different word.
Hello, Mr. Bly. Okay. So let's go back. That has the answers on it. Okay, so I'll go with that. It didn't work, the animations didn't work. So I'm gonna go without the slide because the animations didn't exactly work. So we are gonna talk about ratios. Does anybody have any working knowledge of ratios who is not a math teacher? Something that you compare to something else. Can you give an example? Can you give an example of a ratio that you might use?
2-to-1 mix, which is gas and oil.
Okay, so 2-to-1 gallon to oil. Okay.
So 2 parts gas and 1 part oil, something like that.
Very good. Can somebody think of another kind of ratio, Mr. Springfield?
Gold differential.
Huh?
Gold differential.
What do you mean gold
Gold
differential?
stored to gold allowed.
Oh, that's true. A common one used in classrooms is boys to girls, right? How many boys there are to girls. We're going to talk about the different kinds of ratios, and the first kind of ratio that we're going to talk about is a part to whole ratio. So you have some starburst in front of you, and I would like you to just put those together, and I would like you to tell me, oh no, they're separate. You have your own set. So you should have your own set. There should be 5. So we're looking at a part to whole ratio. How many starbursts do we have in all? Another word for whole is all. It means all together. And guys, if y'all think I'm speaking to second language learners right now too, to make sure that they understand that whole means all. So how many do we have in all? And then how many are red? Who can tell me mathematically, how would you describe the part to whole relationship if we are looking at the 3 red starbursts? How could you tell me? 3/5? I'll write that down. 3/5. What's another way? Huh? Say it again.
I said it doesn't.
3 what?
3:5.
Okay, but 3 what?
Three
3 red,
starters.
2, 5 candies. Is there any other way you could say it? Mario?
3 over 5. 3 with a 5 line is 5.
3 red over 5 total. And this is our part 2 whole. Is there any other way you can say this? Huh? 3 out, thank you. 3 red out of 5. And finally, what's one more way to say it?
I thought that's a percentage, but that wouldn't be a ratio then.
A percentage wouldn't be a ratio? Why not?
I think it would, because it's a percentage is part of 100. I mean, it's.
So part whole, so you could write it as a percent. I just know that. I mean, that's kind of higher math, but some person might not be able to get there. Can anybody think of another way to say it?
Every 5 candies, there are 3 red.
Thank you. That's what I was looking for. Can you say it, please?
For every 5 candies, there are 3 red candies.
Okay. So can I say 3 red candies for every 5?
If you want to.
Okay. So we could say 3 red candies for every 5. Okay, so those are all the different ways that we could describe the mathematical relationship